The next presentation is by Scott, N7SS, Introduction to DSTAR. And I'll for one say that I don't know what that is. I keep reading about it on the internet. These people keep making comments, and I hit delete because I don't know what they're talking about. So hopefully, after Scott gets done, I'll know what they're talking about. So if you can give us a little background on yourself and then start the presentation.
All right, well, my name is Scott Honaker. I'm the current president of the MicroHAMS Club. Thank you all for being here today, by the way. I'm glad it turned out so well. We kind of got started late and got things pulled together. So what I wanted to talk about today was DSTAR. This is a pretty introductory thing, and that was a little out of necessity because that's kind of where I am. So I'm certainly no DSTAR expert. There's a couple of guys here that are jammed much better than I am, I can assure you. And where did Dean go? Anyway, he's been playing with. There you are, in the back. We've got some demo stations set up over there. I have some ICOM gear, and then these guys actually brought their DSTAR stuff just coincidentally. So anyway, what I wanted to point out is that, let's see here. There's more and more digital stuff invading our lives, right? We've got here to talk about some DSP and software-defined radio functions. Right now, a lot of the manufacturers are producing DSP radios, which are a little bit of a hybrid, half analog, half digital, kind of like hybrid cars. The goal, of course, in cars is to get to an entirely electric car, fuel cells, whatever, and that's ultimately where radios are probably headed as well. They'll have an entirely digital backbone. There'll be very, very little RF left inside the radios. It'll look far more like the stuff that Lyle's doing than the stuff that these guys are producing today. Interestingly, hands still tend to use analog voice, although most of that stuff is going away in almost every other service. Satellite TV, it's all digital. DVDs, CDs, your music that you buy, the videos that you watch. Unless anybody still buy tapes? Buy tapes. Anyway, that stuff's like about the last analog thing left around, right? I still have, a turntable in a garage, but it hasn't been plugged into anything in a decade. So, 8-track, yeah. You still have one of those that hasn't bound up and broken yet? Yeah. So there's some actually very cool things. Cell phones have already gone that way. This digital radio mondial thing, the shortwave broadcasts that are coming out of Europe, I think is pretty much exclusively where they are at the moment. I've heard some of those recordings over the air. Some pretty cool stuff, very cool multi-channel audio or really high quality. They can split the bandwidth any way they want. It's incredibly versatile with what they can do. Broadcast text along with the audio tracks, all kinds of fun things, just by making them digital. There is actually a specification for DSTAR. DSTAR is a digital smart technology for amateur radio. It's designed to be a digital standard for amateur radio use. There are a lot of digital standards out there and for various applications. This one is specifically designed for amateur use. It was a joint venture between the Japanese government and the Japanese Amateur Radio League. It's an open specification. ICOM is the only current vendor that has any selection of equipment. Kenwood has kind of signed a memorandum of understanding, and that they were going to do some development as well. Haven't seen anything from them yet, and I don't know what their status is, but hopefully someday we'll see some more radios. The radio products all offer an analog mode for backward compatibility, so if you buy a DSTAR radio, you're not stuck with the digital radio, no one to talk to. You still have an analog. Well, what you have is a very expensive analog radio. So this is to give you an introduction to the DSTAR modes. Basically, all these radios have another transmitter, whatever modulation scheme inside that allows them to do digital, and they can do both voice and data depending on how they're set up. And in digital voice mode, they use this 3600 baud data stream that's AMBE encoded. They also have the ability to do digital data simultaneously. The channel itself is about 4,800 bauds wide, and it's, I don't have the actual width here, it's 6.3 kilohertz, which gives you about 48 4,800 baud, and they divide it up, 3,600 baud for voice, and they actually advertise about 950, there's some overhead, 950 for data. So while you're keying up, it transmits your call signs. You don't actually have to ID when you're using DSTAR because the radio's automatically ID for you. It'll transmit some call sign information. You can transmit short messages, things like that, all simultaneous with your voice. The interface is pretty straightforward. It's a 3-wire COM port. It looks almost exactly the same as the Kenwood cable, the 3-pin sub-mini connector out to a DV9, the same cable. And that's for VHF, UHF, where the bandwidth is limited. When you go to 1.2 gigs, of course, we have much more bandwidth available, and they can do digital voice, which is the same digital voice. They can also do analog voice. But the digital data, they have a modulation scheme that uses 100 kHz wide, and it allows up to 128 kbaud. And then instead of using a serial port, it uses a standard RJ45 jack, and it gets addressed via, it looks like a TCP/IP port. It's just like a network port. So the standard connections that you might see, you have radio to radio, so plain old simplex stuff. You can do radio to radio simplex digitally. You can send radio to radio data, or the voice and data that I mentioned, where you can kind of interleave some amount of data on top of the voice signal. Radio to repeater, you have the same options. You can, through a digital repeater, you can send voice or data, or voice and data, by splitting that bandwidth. And you can do, there's another system they have, in fact, I'm not sure that this component exists yet. They're a repeater-to-repeater gateway. So you can actually have 2 mountaintop repeaters linking each other together, and only one of them has to be tied to the internet. The nice thing about, you can actually tie the repeaters together over the internet as well. And to some extent it works, conceptually it's easy to think of it like a Echolink node or something like that. But it's all addressed by call sign. There's no random node number or something like that you have to remember. You can actually just type in the call sign with your destination repeater. So I can say I want to go in here at N7IH here in Bellevue, which is the icon repeater here, and I want to come out at K5TIT in Texas. I just put those 2 call signs in my radio, and that's it. That's what I'm doing. So why do you want to use digital voice? Analog works, right? Who cares? Well, the first reason is spectral efficiency. That's the same reason that the cell phone providers all went digital. How many people still have an analog phone? Yeah. How many have one that works? Yeah. I mean, the cell phone providers were able to get multiples, 5 to 7 channels in that same analog phone channel space that they had previously by going digital. In this case, we're looking at FM voice with a 5 kHz deviation. You're looking at a signal somewhere between 15 and 20 kHz wide, right? The digital voice mode in this is 6 kHz wide, so you can have twice as many simplex channels or repeater channels, whatever, in the same amount of spectrum. And given the fact that today, if you think about, anybody tried to get a 2-meter repeater very recently in Western Washington? I don't know, you have to knock somebody off, I think is the way that works to get one. All the spectrum is used up. It has the ability to share spectrum with data. You can actually, you don't have to differentiate a data portion and right today we segregate data from voice because no one wants to have to listen to the screaming, right? Keep that data, the noisy data stuff, that racket far away from voice guys. We don't have to do that with DSTAR. It's all digital. The only question is whether the data is voice or whether it's just some other kind of computer data that you're sending. So I mentioned that you can send messages and call signs, things like that. There's also a system that's called DPRS, which is the DSTAR version of APRS. And if you plug a GPS into the radio, in fact, this radio, I forgot the antenna. This radio has an actual GPS module built in. There's just an antenna jack right in it. And so in addition to having the standard voice, or the standard, I can't get the face back there, head back on. Your standard voice channel, you're simultaneously on the same channel carrying that APRS data. And if it goes into a repeater system, it can get gatewayed out to findyou.com, and it's going to look exactly like an APRS system, except unlike your D700 where you've tied up a VFO just to beacon on APRS, this is going through your standard repeater, whichever one you happen to be talking to already. You don't have to dedicate a VFO just to be doing APRS. And voice QSOs are routable. So like Echolink, where you can bring up a node and you can hook two repeaters together, I can actually route my call through a repeater, and I can actually hit a specific person on the other end. So I can say I want to go from here and set IH, and I want to go through K5TIT, and I want to talk to, and I can put in the destination call sign of the guy I want to talk to on the other end. And that's who I get when I key my radio. So a lot more like a cell phone call than just hooking two repeaters together. And set the destination on CQ. Yeah. So it's actually that's a pretty clever feature. You don't have to actually necessarily know everybody's interchange. That's true. I don't actually have to route to a specific, as long as I have the destination call sign. The call signs are all maintained in a database online. Yeah, in fact, you can go to, I do have a screenshot. In fact, you're on the bottom of the screenshot, the DSTARusers.org, and you can see all the last contacts on the screen. We'll see it here in a second. And it's like 2 slides away. And you'll actually see the list of users that have recently kind of basically connected to any machine in the system. And yeah, you can actually just put in a destination call sign. You don't even have to specifically route it. So what this actually means to in any one individual is the radio knows your call sign. You don't have to ID. It's already being done for you. When I press the push to talk, my call sign will appear on the other radio. You can enter a call sign, or you can have a call sign squelch. So I can have a system that actually identifies call signs rather than tones and codes and all that other stuff. I can call anywhere. The voice can be sent through a repeater or routed through a gateway via the RF out to the internet, whatever. The systems are all potentially interlinked. And here's the DSTAR users are registered with local repeaters for cellular-like service. They actually have a kind of universal registry of users, so you can actually view that at the DSTARusers.org. And oh yeah, here this is always a joke to play with. There's actually, some of the radios actually have voice memories in them, so you can record messages, for example. So here's my ICOM 9091 AD with the DSTAR option in it. And if I'm away from my radio and somebody tries to call me, all I have to do is set it up to record for me.
7SS's radio. I'm not available at the moment. Please try to call again later.
Now, I don't know why it actually won't take the message. I want the tape message. There's no actual voicemail, just that answering feature. That's the next version, I'm sure. So here's the user registry. Yeah, DSTARusers.org, you can see there. And it shows, when I was doing some testing here, you can actually see where they're going in. So this is, 2 meters in Syria, right? Whatever day that was. Pardon? I don't know that the information is available. I mean, it's obviously available in this text format, right? This is just an HTML page. I don't know if the information is available somewhere else. I've never really looked into that. Yeah, this will scroll on and on, but these little boxes are identical for I don't know how long how far back it goes. Yeah, you can see the thumb here is pretty small. So So this list, I don't know how far back that list might go, but it's a pretty big list. And it keeps track of the last contact each person was on, their call sign, and then this is the repeater system that gave them on into the system. And the letters here, A refers to 1.2 gigs, C is 2 meters, and B is 70 centimeters. Those are the three bands that are supported.
My impression of that thing is that assuming DSTAR is to be widespread, there'll be so many contacts going through that thing, it'll be completely impractical to look at because
Flying by.
it's flying by. So to the extent that DSTAR becomes widely used, that web page is going to be used.
Yeah, at this point, it's actually pretty handy for testing. You can see the times on here are only, well, I mean, even here. These are quite a bit apart, but yeah, at this point, there's not enough volume to justify doing anything else, but it's good. It's a good system to test with. You can see if you're making it into the system, things like that. They're not there anymore. Yeah, even this is over the period of, what are we looking at here? This is about 10 minutes worth of time. There's only 4 guys on it. This is somewhere in the interconnected system. So. Not the list of repeaters, but the list of users in this system is replicated and available to all the gateways. So if you key up, your gateway can contact the owner of this registry, and it will automatically route your call to that other gateway. Yeah, and now the trick there is that as far as using the repeaters, you don't need to know tone and all that stuff. You just put in the frequency for the most part, because there are no tones anymore, right? And you put in the call sign, and and that tells you that I want to hit that repeater on that frequency. So it's call sign and frequency. That's all you need to know. So.
This thing here doesn't really like America.
No, it's worldwide.
My impression is that the developers in Japan, they don't see it.
Because they can't use it. Yeah, there's actually, didn't I see one in Australia? I'm bringing it in, yeah. So yeah, I actually did see here just the other day. I saw Australian call sign on the system. Yeah, there's some issue with. The funny thing is, there's some issue with the Japanese current regulations that don't, despite the fact that this was a joint venture with the government. There's some issue with the Japanese regulations, and I don't recall what it is now. But, oh, is it? They're using this for government machines? Oh, interesting. So they're not necessarily going to be participating in this list anyway. Maybe. Right. So you can certainly put up a repeater and not have it participate in this gateway. There's nothing to say. Just like today, you have an analog repeater, you don't have to have echo link, right? You could still put up a repeater and just have it be a digital voice repeater and not have it gateway. So certainly not every repeater that's on the air is participating in this system. However, I mean, for my own personal use, if I was going to stick up a repeater, that's the first thing I'd be doing is hooking it into the system. That's on the phone. Sure.
So this repeater, this routing with the call sign, does it need the internet to make that route? The repeater can do it without managing the gateway or internet?
If you want to be able to route to another repeater, you have to have some kind of link. The default link is kind of the easy link is the internet. ICOM is coming out with that 10 gigahertz backbone, and ultimately you could do any solution that gives you an internet connect, a TCP/IP connection from point to point at a suitable speed is going to be adequate. There's no reason why it has to be an internet connection necessarily. It doesn't have to be live. If you want to just tie two machines together, You can do that without having to do an internet backbone if you don't want to. Go.
And again, they thought about taking a current 2-meter channel analog and also super a digital stuff that the two systems work together, make a differentiation between the old analog system and the new DSTAR system. Two systems, so the person has a chance to upgrade normal, just the DSTAR will all be able to be differentiated.
Well, generally, you're going to put in a digital voice mode, just like we don't do sideband and FM in the same spectrum today, right? Because they're pretty incompatible. The radios actually have a mode that's an auto detect mode that lets them use their DSTAR detector to also detect FM signals, so they can switch back and forth. But because the deviation of these signals is different, the FM performance is not. I haven't actually tried it myself to know what it sounds like, but in the manual it says right flat out that it isn't going to give you a very good sounding FM signal because we're using the DSTAR equipment to do that.
Well, what I'm looking at is, everybody currently has a spectrum full of analog systems, and when I look at those systems are all going to die out in 20 years, being able to superimpose a digital system that is not very compatible with an analog system. That analog system, anybody out there analog, may use the analog version, anybody on DSTAR uses the DSTAR, yet still the same frequency, same.
Right. So here's what we're talking about, right? So I should probably turn this the other way. The trick is, if you're using a legacy radio, you're going to have the opportunity to. Let's see here. You're going to get to listen to that every time there's a DSTAR user on, right? So, I mean, even though the DSTAR might... Yeah, well, yeah, there's that possibility too. Yeah, that's true. We can try that. So that gives you an example, too, of what that modulation scheme sounds like. And here's the other one that I thought was kind of entertaining. Just like your cell phone, you have a little bit of latency when it does the encoding, when it does the analog to digital conversion. So you have, so you have that funny delay, just like, remember we used to get when you make overseas calls or something like that, it relays through the satellite and everybody tries to talk at the same time because you don't have that natural full duplex sounding thing. Well, that happens here as well. So, let's see if I can. Now they're not even going to do it.
So if you hear live voice, here's what's coming through the radio. You can see it's like a really bad PA system.
Like I'm in a stadium or something. You can actually get it. Actually, if I turn the volume up a little more, I can probably get into feedback. The digital feedback is interesting sounding too because it isn't the standard, high frequency squawk. That's digital feedback. Yeah. Well, the spec is published, and anybody can go download the spec. It's available from the JARL's website. You can go to the ICOM website. They'll print it there. You can print it from there, and they'll point you back to the JARL website. It's open. It's an open spec. The trick is, Kenwood has announced that they're going to be developing for it. They just, it's hard to tell how motivated they are because they announced that a while ago and they haven't come out with radio. Not that product cycles are instantaneous, right? You can't say, I want to publish, put out a radio and it's not going to be on shelves next week, right? Or in this case, it's been like a year. But even that's a relatively short product cycle. Oh, Kenwood does have one in Japan? Oh, that's interesting. Okay, I seen it. That's cool. Okay. Yeah.
Can you talk about HMO applications of digital voice?
Well, there is probably no, especially based on the playing around that I did a little bit, there's probably no digital DSTAR version. Certainly not this encoding scheme. This doesn't work. It's definitely susceptible to phase noise and multipath distortion, right, which is the very definition of HF communications. So this is not going to happen on HF. Not that you couldn't implement a different encoding scheme, but and offer similar features even. But DSTAR, this under the current encoding scheme, isn't going to happen on HF. So.
Do you know if anybody has tried to implement DSTAR with software-defined radio, one of those $20 radios?
Well, I haven't seen anything like that. The trick now is that the ICOM shopped around for a long time to try and find a good voice encoder, and this voice encoder has some interesting characteristics. It certainly doesn't sound natural. It's not hi-fi by any stretch, but it's a very good voice encoder. And what's kind of funny is when I use a handheld or something like that in the car, all the interior car noise tends to go away because it doesn't have any way to compress random noise. It's designed specifically for compressing voice. So background noise tends to go away. So you have a very clear audio, even though it's a little mechanical sounding. But unfortunately, the compression scheme is owned by a third party. They bought some chips from, I forget who the manufacturer is. So the compression scheme is hard-coded into those, and that compression scheme, that A and B in compression, is proprietary today. I'm waiting until somebody reverse engineers it. I wonder how hard that has to actually be.
Yeah, this is a third-party digital voice product that you buy now.
What wants
AOR products that folks are using today. It's used, when the protocol they use here, different things that, some people come out with
Well, the trick is the AOR digital thing, which is there's your HF solution today, right? Is that AOR box is designed to work with a standard sideband radio, and this was specifically designed to be narrow bandwidth. So unfortunately, there's no normal transmitter that's going to give you that 6 kHz wide signal. You'd have to significantly modify your transmitter. So I mean, normal FM, even an FM narrow signal is substantially wider than that. I don't know how, I'm not sure how you'd have to get into the rig somehow and actually inject that. Yeah, that's true. Yeah, it's not even an FM signal in the first place, right? So it's 6 kilohertz over transmit. That's your actual full bandwidth. There's only one in the Seattle area, and it's down as deep as they could dig in Bellevue at actual ICOM America. So I'm able to hit it from like on the top of the upper deck. I was able to do pretty good getting into it, but they put it. I don't know if you know where ICOM America is, but it's about as low as you can get in Bellevue. We'd be surrounded by hills, and yeah. So.
Basically, ICOM set that up for
Yeah, they just use it as a test system. Oops, where did it go? I was going to say, if you really want to try and actually receive some squawk in front of it, somewhere here I have the frequencies. I never remember. Yeah, so on 70 centimeters they're 443.575, and on 2 meters it's 145.290. Yeah, there are systems that are sold. There's several systems that are actually sold into the area. They just haven't been put on the air yet. So it's not as if they don't exist. They just don't exist on the air. I don't know. 50? I haven't seen the number. Yeah. It was interesting to me. I actually went to a show in Atlanta, the Stone Mountain Hamfest in Atlanta, Georgia, and the HRO Atlanta actually sold out all their DSTAR equipment. They have a repeater up there, and they actually had the, a system set up and working, and those guys were just eating it up. And I was thinking, wow, here nobody even knows what it is, and there everybody's buying them. And I thought, it was amazing. The multipath is an issue. And yeah, right. Yeah, the guys in Texas and K5TIT guys, they really put up the system. But they've got, they're 1,000 feet up, and they've got, flat real estate. So. Jan can tell you.
There's got to be 3 reviewers out there. There's one on Salt Spring Island.
Really, on Salt Spring Island too? Really? That would have good coverage. Wow.
Aleco has digital radio about 2 years ago.
No, I don't remember. I don't recall anything digital Aleco. What was it? Oh, that's right. I remember that thing. Okay, yeah. Right. Yeah, they had some other proprietary thing. Yeah, but I've never heard one. Well, the other interesting thing, and I don't. I'm going to touch on this here shortly, but the other interesting thing that for a government use or like RACES use is that you have some degree of privacy, right? So you pick some completely proprietary modulation scheme, and boy, nobody's going to be listening in. So, yeah, it's not. I mean, for that purpose, if that's your purpose, yeah, whatever works. So, and how is this different from IRLP? Well, first off, you don't get call sign squelch. You can't call an individual user. You're linking repeater to repeater. So you've got public communications on either end of the system. It's big time party line, right? Call routing isn't automatic. You have to know the node number of the node on the other end and type in all the codes on your DTMF keypad and all that stuff. So there's you have to do the DTMF code sequence. In DSTAR, you can actually, if somebody calls you, you can actually record that information into memory. You can put it back in your call sign memory. You're calling people by call sign rather than by some random number. I mean, there's some chance. I mean, not that I have a great deal of luck remembering call signs, but it's certainly better than remembering 5-digit numbers. Right? You can't send any other data. You can't send call sign, messages, position, or other data to the remote users. And again, here's the point about you have some level of, it's the security through obscurity, right? Where right at this point, you have some amount of privacy by using a DSTAR system.
I'm on DSTAR, and I call you specifically either direct on simplex or through some set of repeaters. I'm calling you specifically. Does anyone else that intercept that RF have to be able to listen in on that user?
There is a mode. I can't remember how those modes work. So simplex you'll hear both sides, but routed you only get one. The call sign squelch, right? There are 2 other modes as well that are kind of interesting. So there's a break-in mode, which I was trying to figure out exactly if that would apply in some fashion. But the one that's interesting is there's an emergency mode. So if, for example, the wife has the radio she's monitoring at home with a call sign squelch, okay, see you. That's probably the end of my battery. If somebody transmits in emergency mode, even if they have a call sign squelch turned on, it's going to open the radio and put it to a preset volume level. Or if you have your volume level turned down and somebody keys up in an emergency mode, all the radios come up to a listening volume level that's preset in that radio, and your call actually goes out to every listening user. Again, one more feature that you get when you're digital. So as far as digital data, why is this interesting? We've got DPRS position reports, much like APRS. I mean, you've got, this one has a GPS built in, the other ones all have data jacks. You put them in that mode and they broadcast your position data. And again, it gets picked up by one of these gateways and get put into the Find You system. You can transfer any type of data. There's no limitation. This isn't 7-bit text or anything like that. It does real bit data, so text, photos, emails, spreadsheets, whatever you want to do. On the low-speed units, it interfaces as a COM port. It looks just like a serial port. And on the higher speed units, on the ID1 at 1.2 gigs, you get an actual Ethernet connector on the thing. It's routable to anywhere in the system where you can gateway it to the internet. You can actually go, off the shelf. You could buy one of these radios and be 128 kbaud at 1.2 gigs, no building those. Remember one of those Graves systems that were the 10-meter rig, there was a 10-meter driver and then a transverter and then some funky high-speed serial ports, and yeah, you could buy these and plug them in, and they work. So yeah, you don't have to mess around with building something and soldering together your transverter and all that. So obviously, Packet or WinLink are also options for sending data, and they all work. They all have their place. But in the case of Packet, there is this concept of a roaming IP. Normally you have to get assigned an IP address, and it's only good for a very small region of space. There's this concept of a roaming IP, so if you go somewhere else in the system, you can get reassigned an IP address that's local to that. I don't know anybody that's actually implemented that, even though it's kind of in the spec. So you can't just go anywhere and get into the system via TCP/IP. You can if you're using DSTAR. It doesn't make any difference where you are. Packet protocols are unique to ham radio, so getting a normal piece of software interface to your TNC isn't exactly like just plugging it in. In this case, you've got a COM port or a TCP/IP port that at this point pretty much any piece of software understands. WinLink only does email, and you can do some attachments as long as they're not too big. And again, it's a great system, but it doesn't let you transfer raw data or get internet access or something like that. WinLink is supported over DSTAR. Again, as a transport, it works just fine. Yeah. Well, the radio itself gets assigned. I don't remember how the ID1. The ID1 is the only one that does that. And I actually haven't had a chance to use one on the air, so I'm not clear how that works with the gateway and how it actually hooks up. But well, as part of when you're in voice mode, for example, it sends your call sign out and the destination call sign or any routing information. It transmits that automatically when you key down. It's part of the digital data stream. It interleaves that data. You can send short messages like status text in APRS. You can send as part of your when you hit push stop. Right. Yeah, the packet system is all, again, that's all published, but there's they digitize the voice and they interleave data with it. Well, so the other guy can decode it. Well, I mean, the same way you do with a packet transmission, right? It's part of the packet encoded transmission. The structure of the packet, yeah.
When did I miss that thing anyway, to upgrade?
Scott announced it at lunchtime.
I never heard a word. I was sitting over there the whole time.
That's fine. That's fine. I think we can still take care of it.
So again, the last thing here obviously is that, well, WinLink is supported over DSTAR just because it looks like a serial connection. It looks like a direct cable connection, right? So you go into AirMail and say you have a direct cable connection and you're good to go. And then you have off-the-shelf solutions for high-speed and low-speed data. So what do you need? There's full line of products available now from ICOM. They just came out with another one as of, well, it isn't available yet actually. This is serial number now for this guy. This is a dual VFO mobile, and the serial number is written in Sharpie pen so you can tell it's ready to go. Kind of clever, the head's removable. It's stuck, it's has magnets, so it will mount to any metal surface, any steel surface. And of course they have the GPS module in it. Yeah, it does diversity tuning. Actually, I have a slide on it. So. But you can see there's a bunch of different things here. So the 2820, this is the guy here that I was just showing you, is the new mobile. The ID800 is a single VFO dual band mobile. They have a 2 meter and 70 centimeter HT. The dual band HT is here's the single band HT. That guy. And that's available in 2 meters and 70 centimeters. This is the dual one, that's dual VFO. And it has the fine answering system on it. What else? 2 meter mobiles. You can buy these guys, the IC2200 is the standard 2 meter mobile, FM mobile. And they have a module in it, that UT118, that makes it DSTAR compatible. It gives you the digital mode. And then the 1.2 gig for ID1 I have back over there. And then there's repeaters and all that stuff that are compatible with DSTAR as well. It seemed to me it's about $200 when I looked at HRO here a little while ago. So that's the UT118 module. So it's about $10 more than a KPC3 Plus. So, yeah. I don't remember the handhelds. Boy, I don't remember any pricing actually on the radios. Like the VE82, that's their 160, something like that? Somewhere in there. I mean, they sell it as an analog rig, so it's pretty price competitive with the standard analog rig. And then for another $200 you install a module in your DSTAR compatible. So they're the two handhelds. The mobiles, that's the standard 2 meter mobile up there. Again, it starts out as an analog radio. For another $200 you can install the DSTAR module and make it digital. This is the picture of the 2820. This is the new one, dual VFO. Has the GPS built in with the DSTAR option. Has diversity antennas on receive. So one of these is the transmit antenna, and the other one is actually a second antenna for diversity. So you can get rid of I mentioned that it's sensitive to phase, noise, and multipath. I think there was a reason why they chose to put diversity in this radio. Eliminate some of that. Really? Yeah, you can see it doesn't, in fact, what's funny to me is it looks surprisingly like a Kenwood D700 speaker. In fact, the menu structure is very, very similar. You hit this button and you toggle through the 3 sets of menus, just like the D700. And you have the digital display here with the numeric display, and then right above it is actually the text menu, the text memory names, just like the D700 display. Oh, yeah. Yeah, it'll scroll right where it says hi right here. It'll actually scroll text across there. If I bring up the menu, if I hit this, it'll actually show the menu down here as well for these keys along the bottom. I'll plug this thing back in so we can play with it. It doesn't have a TNC built into it, so there's no way. I mean, you'd have to supply. I don't think you can get that data out of it even necessarily. little gateway over to the APRS system. Oh, interesting. Yeah. So there's, yeah, I haven't. The manual for this is still marginal. I read a few pages. I read a few pages multiple times. Well, there's less Japanese in it than the radio I find, but 7,000 manual. You did a great job on that 7,000 manual. Did you? I don't know how you. I read in the original 7,000 manual. I read some stuff, and I don't know how you figured out what that stuff even was. I had the radio when I was. I don't know what this is saying. So the other fun thing is that the head is magnetic, so you can mount it. Well, it's hard to show here, but you can mount it any number of ways, either above or below the rig. If you want the speaker on the bottom, you can do that too. Just flip it over. Kind of a clever mounting system. So here's a portable UHF 1.2 gig repeater system, you know, a little rolling cart that was down at what is it, the Alabama section manager owns the system. And you can just roll it on in. And pretty impressive. There's the cans and everything all mounted up, there to go. He strapped it down the back of his pickup truck and drove from Alabama to Atlanta with that thing. So how much does it cost? Here's the V82, U82, 2200. These are prices I pulled off the HRO. So there's the module, $199. And again, if you want to compare that to, you know, take an analog radio and make it digital, the way you do that generally today is KPC3 is kind of the standard, right? At $189. So ID91, that's the analog version. There's the digital version. That's a little better deal. So that's what I bought. The ID800, 629, and the ID1, which gives you 128 kBaud data off the shelf for $999. So, I guess my last point here was I want to make sure people understand that hams have this weird concept that because things are changing, that things are getting worse. Like, no, there's a huge opportunity here actually with these technologies. Microsoft uses this phrase, embrace and extend. So it's, you know, just because the whole world has gone to the internet doesn't mean people are going to stop buying software, right? I mean, you got to go after that. If that's where everybody's going, you got to get out, run faster, and get out in front of them and figure out what it is they want and make sure that stuff happens. Most media, all the media is now digital. Interoperability, that's the big thing we've been hearing from all the served agencies. And having something in a digital form you can easily move back and forth instead of trying to photocopy stuff and fax stuff. The last one, the Honaker floods, they were trying to fax something over and nobody could find a fax number. I'm like, can you not just email this thing? You have it in a digital form. Somebody had to print it out, then they have to find the fax number, get the fax machine, like just email the thing, you know? But they can't do that, right? Like, anyway, served agencies are expecting more now. Snohomish County is installing a system called WebEOC. The whole thing is going to be web-based internally. There aren't going to be any more paper, forms, all that stuff. So. I haven't seen the system. They're actually installing it like right now. They're probably going to be done in a month. They've had to rewire the whole EOC, put in all new computers, all these big screens on the wall, and so I haven't seen it. To it?
We had a chance to work on a better way to take our EOC and bring it up into EOC and practice one. Now that was working, you know, it's like coming out with Vista. When you came out with Vista in 1995. Oh?
Yeah, kind of the way it should be. Well, yeah, it'd be interesting because if you could remote those web screens, then you know, through something like this or any kind of a high-speed data port, that'd be very cool. Right. Because VPN is so insecure. Wow, that's a pretty tight IT guys for that. So yeah, I mean, we actually have there's some pretty cool things. One of the Snohomish County helicopters has a video camera on it. They feed it down, it gets digitized, it gets fed to all the screens of the system. I mean, this media is all digital. And then here's some sources for stuff. It was interesting to me to see DSTARs in Wikipedia. It's kind of fun. It's actually a pretty good thing. It was a good source for information. Any questions? Any more questions? Well, that was easy.
Okay, thank you, Scott.